I'd love to talk a little bit about your transition from sort of that middle career to the different technical advisor roles that you played, because I think people's conceptions of what a technical advisor is like could probably be a number of different things. So we'd love to get a little more information about how did you have to evolve as a leader to operate at that scale or that breadth where you're working on these global initiatives, and a lot of these really big programs have made a huge impact.
Okay, well, first I'll start with what is a technical advisor. What was it, 2017 or 18? I can't remember when we started, but we acquired LinkedIn. Microsoft acquired LinkedIn. And along with that came a head of engineering, Kevin Scott, and Satya Nadella, Microsoft's CEO, made him CTO, Chief Technology Officer of Microsoft. And they had to create an office, the office of the CTO. And somehow my name got in someone's hat and they pulled my name out and said, so I got a phone call, and an email, how would you like to be, technical advisor to, Kevin? And honestly, I thought it was a joke because like we have a CTO, you know. And a technical advisor is roughly, if Kevin, you can imagine Kevin Scott as a justice of the U.S. Supreme Court. Well, justices have people that work for them. The various pages or I forget what you call those people, but they do a lot of groundwork and they hand information to the Supreme Court judge, and they write their opinions. The technical advisor is similar. Kevin has a job, which is to lead the company technically through the next, where are we going in 20 years, right? And why and how. And that requires a lot of knowledge of what's happening in the marketplace, what's happening inside Microsoft, um, and steering us, right? Which is a pretty tricky thing to do. So my earliest role was to help us define what was this office. I was one of the first. We hired two more technical advisors soon after me, and we grew that office. So I do a lot of synthesis, like looking out in the industry and saying, oh, given this, this, and this, which is happening in microcontrollers, um, I believe this means this is what the future of microcontrollers is going to be. This is what we should do about it, right? And I might hand that over to Kevin, and he'll go, "Oh, okay, that sounds interesting. Yes or no, whatever." He uses it however he's going to use it. Um, so that's one thing, is like you're a synthesizer, and you can do that because, at least in my case, you have a breadth of knowledge of the industry because you've been around a while, or maybe you even know a lot of people in lots of different places. And I know the company because I've been in the company for a while. So I know our culture. I know the kinds of things that are going to work or not going to work, how you have to try to convince people to do something or whatever. So as a synthesizer and as an internal politician, you're pulling all this together, handing over an opinion. The job is not to run all over everybody and say, you will do this. It's like you'll be shut down in a second if that's your attitude. So it's much more humble than that, where you're just trying to serve the company, right? And serve the CTO. So that's roughly what that technical advisor role is. And it's not, I'm not currently in the office of the CTO anymore, but the label sticks with you because you're always a technical advisor no matter where you go. It's kind of like Donald Trump was president, and he's always going to be called president, because he was. So that's how it is. I always have that advisory role no matter where I am in the company.
In a lot of sense, if you're helping support a lot of folks across the entire company, there's less sort of formal positional authority, and it's very much driven based on your ability to influence, communicating, and gain buy-in. How'd you build that skill set?
I think part of it is, well, first of all, you have to have some credibility of some sort. And I would say my credibility came from a long history of actually delivering software, and helping engineering teams get built. So I lived in India for 3 years, for example. And what I did there was train our engineers on how to be better engineers, or how to be engineers, because there are a lot of college hires. So I had credibility as an engineering leader. I had credibility as an engineering builder, helping to build engineering in a different country, right? So I had credibility amongst a lot of people, right? So if I say something, they're willing to have a conversation with me, right? Because like, oh yeah, okay, we know you, and we know you know how to ship software, and we know you know how to build people and all this other sort of stuff, so we can have a conversation. If I just showed up out of the blue and I was hired 3 months out and I didn't know anything and hadn't proven anything, it's like no one's going to talk to you, right? At least not at that level. So I had credibility. And then there's transformation and desire. So I had the ability, I had the experience, and I had the desire to do this kind of work. Not everyone does, right? It's not a for sure career builder sort of thing. It's like um, you're usually going into a role like that because you want to get exposure to the breadth of the company, because that's what you do, and the breadth of the industry, right? So it's really something you're not going to do probably when you're 20 because you don't know enough, to be advising at that level. You had to have seen a lot of systems being developed over time and have a sense for predicting the future. You need a crystal ball, and it's got to be fairly, maybe not reliable, but at least it has to be used, right? It needs some mileage on it, with some wins in it. So it was a combination of those things where it's like there's history, there's experience, there's desire, uh, and there's ability to predict the future, and someone has to pick you. Right? So there's luck, if you will.
I'm really interested in the synthesizer skill that you had mentioned because one, if you could tell us how to develop a crystal ball and you predict the future, amazing. But I was wondering if there was like a framework or a series of questions that help you synthesize information and present it. Because I'm thinking for probably anybody in many roles, like the ability to synthesize complex information, especially if you're communicating outside of the engineering context, is an insanely valuable skill set. So how would you might recommend somebody to become a synthesizer?
If I had to narrow it down to two skills, one is the ability to just consume a lot. I am a regular reader of code, for example. I read way more code than I ever write. So I'm in GitHub looking at projects, just seeing what people are doing, different techniques, styles, blah, blah, blah. So reading code, reading tech news, right? Um, I like everybody else, ycombinator.com and TechCrunch, whatever. You gotta read and see, well, what's happening, what's happening, what's happening. So there's a lot of consumption of just data, raw data, right? The predictive part of it uh, comes from, it's just pattern matching, right? So it's being able to draw the lines between the dots and say, oh, this happened. Let me backtrack and see why this happened, right? Um, it would be hard to predict that AMD would be in the position they are in now relative to Intel. AMD having recovered from near disaster of being irrelevant, but they did something in their architecture uh, where they said, okay, we're going to have these low power cores and we're going to have a lot of them. They made that turn about 10 years ago, right? Whereas Intel was still like, single core super duperness. Um, they made that switch. And so their architecture dropped them down in power requirements for the equivalent computation, right? And 10 or 15 years ago, whenever they started doing that, you might have thought, yeah, well, whatever. But if you look forward and said, okay, data centers, what are data centers about? Well, they're about turning um, sand and electricity into dollars. That's what a data center is, right? You take sand, you turn it into silicon, you pour in electricity, and people pay for it. So the cheaper you can do that, which means power, your power consumption has to be down. So the amount of power per transaction, if you can win that game, you're going to win in the end. And that's exactly what AMD is doing. And that's why they're winning now. So you can predict that AMD is going to be on the rise. They're not going to kick on the data center totally because it's about relationships too and not just power consumption. But you could predict that, okay, Intel is not going to be dominant because AMD's got them on that end. NVIDIA's eating everybody's lunch on the GPU end. Apple is going to leave them, and they did. They got their M1 thing going on. And you could predict that because, Apple's had supercomputers since the 90s. They've been doing chip design. They did it with their A whatever chips, you know, and now they've got the M series. Intel's over there like, oh, they'll be back. It's like, no, they won't. You know, so that one's those are easy predictions, but you have to see it and go, what is that going to lead to, right? Let's play this out. Let's say AMD is right, and this thing does come to pass. What will that mean, right? Let's say cloud computing is going to be the thing. What is that going to mean for the chips? It's got to be optimized power for efficiency. So whoever can do that best is going to be the winner in that game. So invest in AMD 10 years ago, right?